how can we find the angle in this triangle when it hasn't given us any other angles? Now, if you don't know how to solve this problem, don't just stare at the picture. Start by asking, what do we actually know? So let's take a look at the diagram for a moment and read the relationships and understand what this question is actually asking. So we're looking for this angle here. This is angle BAC. And we know that the sides AC, BC, and BD are all the same length. And also AD and DC are the same length. And that's shown by the lines on each of those sides. So what do we know about triangles which have two sides which are the same length? Well, of course, they're isosceles triangles. So if you know something about isosceles triangles, the base angles in an isosceles triangle are equal. So that means in the triangle ACD, these two angles are equal. So if we say what we're looking for is x, then both of these angles are x. And then also in the triangle BCD, since this is also isosceles, these two angles are equal and we can call them both y. Now the trick to this question is that there's another isosceles triangle hiding in this diagram. Can you see it? The whole thing is also isosceles because AC and BC are the same length. And the base angles in this isosceles triangle are here and up here. So this angle up here is also x. Now, you probably remember that the sum of the angles in a triangle are 180 degrees. And now because we've labeled all of these equal angles up, we can form some equations. So looking at the triangle ABC, we know that the sum of the angles in that triangle is 180 degrees. But we also know for this specific triangle, it's x plus x plus x plus y. So from this triangle, we learn that the sum of the angles is 3x plus y. Now, if we look at a different triangle, say BCD, again, the angles add up to 180, but now the angles in this triangle is just x plus 2y. Now we can use this, we can combine these two equations to find x and y. So let's just go ahead and do that quickly. Now you may notice because there's 180 on both sides, the temptation is to subtract one of these equations from the other. So why don't we just do that? When we get that 2x minus y equals 0, we can do an extra step there though and say 2x is equal to y. Note, if you know the exterior angle of a triangle theorem, we could get that directly from this triangle. But let's leave that for now. And knowing that y is equal to 2x, we can then substitute this y in here. So we get 3x plus 2x is equal to 180, or 180 is equal to 5x. So we find that the missing angle is 36 degrees. And that is how you get to this angle when you had no other angles in this diagram. The secret was forming equations. The bigger lesson is when you're approaching a problem that you don't know how to solve, start by thinking about, what do I know? How can I relate the information that I have together? And that is how you become a fantastic problem solver.